Hey everyone, I'm recording from my phone to give you work through these examples real quick. I've tried it a couple times using the computer, and apparently I'm just a boomer and can't figure anything out. But we're gonna do our best. So I'm on the phone, and I've written some of this out by hand. So hopefully, what we're talking about. So the question is, we've got an airline with seat widths of 16 inches. They're thinking about, or 16 and a half, they're thinking about switching them to 16 inches. And with a population mean of 14.3 hip widths, with that standard deviation being 0.9. Okay, so first off, we have to ask ourselves the questions, how does this apply? Well, this is a norm. So they gave us the details that this is normally distributed. So that's great. And then, is this a single measurement, or is this a means, a sum of means? And it is a single measurement. Okay, so they're talking about what is the probability of X. I'm going to try to write in video at the same time. Probability of X where X is greater than 16 inches. Okay, so that's what they want us to find with this, using this variables. Okay, so we can punch it into Excel, and you can see the example on the worksheet. I'll put it up here for you. Okay, does that really help? Well, let's see. Normal dist, and if we go in here, we can see what our value should be. Okay, so that's X of 16 with the average, or excuse me, the mean of 14.3, and then our standard deviation, population standard deviation of 9, and then we chose 1. Well, why are we, what if we chose 0 instead? How would we know that that's wrong? And we got this 0.7. Well, let's think about what we're actually trying to do here. We're trying to find out, okay, so we can kind of see this normal distribution here. And we're thinking 16 is going to fall in between 1 standard deviation and 2 standard deviations. Well, remember, this is going to be 68 and this is going to be 95. So why this should, we were thinking, we could think, okay, it's going to fall somewhere in between 1 and 2. Well, so that's in between 68 and 95, right? Well, this single measurement here, 68.95, is not what they gave us in the answer, right? If you look at the worksheet, it's not with it. And in fact, if we go on and use our computer, we get that number 0.074. So, well, remember, we got to subtract that from 1. So even if we took 1 and we removed 0.0745, we wouldn't get our whatever they gave us. I think it's something like 97. I'm trying not to pay too much attention so we can do this, work the assignment. Make sure I get the right question on here. Yeah, they gave us 97.6. That's correct, but why isn't 0.76? Well, so if we get this, what are we going to get? I'm just going to rough estimate it, and so that'd be 93, something like that. Little, well, 92.5. Okay, something close to that. Why isn't it that? Why isn't it 92.5, and instead the answer they got being 0.9706. Oops. Why is it this? This is correct, but why isn't the other one? Well, does that fit within our number system here, within this graph? Well, we have to remember, and this is why I drew a little extra, we have to remember that we're talking about cumulative. And this is one of those things where drawing this out each time really helps. And you can get faster at this. I spent time because my skills are bad, and if I draw it wrong and trying to explain it, someone will not misunderstand it. We were expecting the value to fall somewhere around here, right? That's not to scale, but that's close. That's where 16 is going to fall, close to that. And so we thought it would be in between our 68 and our 95%. And so it'd be less than 95%. Now in this one here, the answer shows it's 97%. And how is that? So how is that possible? Because 97%, according to our graph, would be over here. So what's going on? Well, actually, remember that it's cumulative. So we have to add up all of these. So we have to add up 0.15, 2, 3, 5, 15, or 13, 5, 34, 34, and close to 13.5. So when we add all of those up, remember that this 68% includes both sides. The 95% includes both sides. 99 includes both sides. And then we have that, well, how do we get 1? I just drew this out just to make sure we understand. You'd go out all the way to, infinity or high multiples. Technically, it could be infinity, but it gets so small so quickly that we put in, and you may get a z value, a z-score of 17 or negative 17 or negative 20, and that's so small it's almost 0, right? Really is 0. Okay, so we just want to make sure we're understanding that we're really wanting to measure this value, and that means that we have to take everything to that side and subtract it from 1. So not just this value and subtract it from 1. Okay, so make sure that we're clear on that. Okay, we go. So that's one method we could use. So we want to make sure that we use. We don't do this. We're not doing this. We want to make sure that we do, when we use the norm distribution function, we use the, and I'm just going to put comma, comma, comma. We want to put 1 for cumulative. Okay, so make sure that we're using the cumulative version, and we got to put 1 in that to get that. Okay, so that spits back 97.02. We go back up here. Let me adjust this. So I have it at 0, and if we hit 1, we're going to do now cumulative, and then we've got 97, and that was the answer that was returned, but I have that being subtracted from 1. Okay. 9706 is rounded. What's the other way we could do it? Okay, well, we could go look it up in the table, the Z table. I know you guys are all excited about those. So let's see if I can pull this up. I literally just had it available. There we go. Open, please. There we go. Okay. So do we want that? No, we actually want this one. Okay, so we're going to find Z for here, but what are we looking for? It's what's our Z score? Oh yeah, we got to do the calculation, right? So our Z score calculation. What do we got? Z equals, and remember this is because this is a single measurement or single sample, as opposed to a mean. We're going to go here, and so what do we got? X is 16 minus 14.3 over 0.9, and that'll give us 1.7 over 0.9, which gives us 2. What is it? No, that's not 2. It's like 1.89. Okay, so Z equals 1.89. Okay, tracking with that, not too hard, right? So let's go now look at our Z-score table. If I can pull that up. And this is why I'm takes so long for videos, and when I try to explain stuff, I just need to get it all compatible. I'm going to try and zoom this in a little bit. Sorry. There we go. 1.89, 1.8, and we can go all the way over to 9, right? Okay, so 1.89, 97.6. 0. And so that I'm sorry for making you sick. We got 9 there, 1.8. Can highlight that all the way across, and that gave us 97.6. Okay. Oops, 0.6. And we're measuring. Wait, we're measuring to the left. We didn't want the left, right? Or correct? See, remember when we drew this scale, we wanted this side. If we look at what the table gives us, it gives us the shaded region to the left. Okay, so now we got to take 1 and subtract it. And what is that? Get out the old calculator, trying to do this as quick as I can. 1 minus 0.976, 0.24. Okay. So what's the question? What's the probability that folks are going to, men are going to have waist bigger than 16? Okay, we got about, a random person will have about 2.4% of the population is going to have a waist bigger than bigger than 16. Okay. Here we go. Sorry for the shakiness. I'm going to load up another video and we'll show the second way to do it.